Hello and welcome everyone. My name is Ian Blanding. I'm a research analyst with the Pacific Northwest National Laboratory, and I want to welcome you to today's installment of the National Energy Codes Conference seminar series. So this seminar, we're going to be talking about energy code implementation kind of at a higher level and learning from myself as well as another presenter on some of the recent research that has been conducted to help us understand how kind of energy codes are being implemented and how we can use those insights for training and education and other implementation related activities. So before we get started, just wanted to look ahead for the seminar series. Hopefully you've joined us on some of these past seminars talking about stretch codes and utility programs. And you can find recordings from those webinars on energycodes.gov. But then looking ahead, we have 3 more seminars in this series talking about zero energy, water and carbon, offsite construction and the intersection of that construction practice and energy codes, and then a kind of a deep dive on multifamily building energy efficiency. So we hope that you'll join us for those seminars as well. And then certainly if you haven't joined us before, thanks for joining, and please take a look at the recordings and slides from previous seminars. Okay, so there's a lot of ground that I'd like to cover today, and so we'll go ahead and get started here. So again, Ian Blanding, I'm a research analyst at the Pacific Northwest National Laboratory, and I'm here to talk about residential energy code field studies. And so you have probably, heard if you've attended past webinars that we've provided or the National Energy Codes Conference, you've probably heard of these. So my presentation is going to be a little bit of a recap in terms of kind of how field studies came about and how new methodologies have changed the way that we've approached energy code implementation and compliance assessment, but then also looking at a new tool that we've developed, kind of culminating all of the residential energy code field studies. So you as the public can get a sense of how codes are being complied with, and where the key focus areas are in terms of energy code compliance across various states throughout the country. And so a little bit of background, energy field studies really, kind of re-emerged into the space of the energy codes world during the American Reinvestment and Recovery Act days. So that was really a critical metric to determine kind of the impacts of energy codes, and compliance was a really key focus area there for states that were receiving some of that funding. And so, field studies started to kind of reemerge then. Back in 2009, and then in 2014, Department of Energy and PNNL really developed a new methodology, a new way to look at energy code compliance from the lens of energy cost and emission impacts of non-compliance. So in other words, what are the kind of the impacts of non-compliance, and how can we assess those impacts and determine kind of potential improvement and the impact of that improvement if compliance were improved. And so DOE funded 8 states to look at, to kind of conduct these pilot studies using kind of a 3-phased approach. The first phase was a baseline study to assess residential energy code compliance. Second phase was to do a training and education program, so implement that throughout the state. And then the third phase was to assess whether or not that training and education program moved the needle, whether or not it generated additional savings that were lost, due to reduced compliance rates, and whether or not it actually improved rates of compliance for various measures. So I'll get into more of that methodology a little bit later on, but kind of at the high level, from those 8 states, there's over 25 states that have conducted a field study using a DOE methodology. And so this map kind of captures those 25 states, but then it also provides some resources on states that had conducted field studies prior to the DOE methodology being released. So there's a lot of states that are interested in it, find value in certainly the field studies, and are continuing to do those. And then here are the 8 states that were initially funded as part of that 2014 funding opportunity announcement. And that was the 3-part pilot series that really kind of generated additional interest in continuing on with field studies and using them for a number of reasons. And so if you're a state or a local jurisdiction, you may be asking, why should I conduct a field study, whether it be residential, multifamily, or commercial? And so there's, a number of value, of benefits and for doing that. One being just to get a sense of how homes, multifamily buildings, commercial facilities are being constructed across states. So from the single family side of things, which I'll primarily be talking about today, what types of foundations are primarily installed in states across the US or in your specific state? How well are homes being tightened up? And if they are being tightened up and have relatively low air leakage rates, do they have mechanical ventilation, and what does that mechanical ventilation look like? And so there's a lot of benefits, both from a code compliance standpoint, but also from a utility standpoint in terms of developing programs and really just getting a better understanding of kind of what's going on within a state or a particular jurisdiction. From an energy code standpoint, really the impetus of these studies was to assess rates of non-compliance and then identify potential energy savings, cost savings, emission savings from improving those rates of compliance. And so that is really important to help validate whether or not energy codes that you adopt are actually generating the savings that they're intended to. So if a state or jurisdiction adopts an energy code, it really takes both the adoption process and implementation, as well as compliance and enforcement, to make sure that homeowners, business owners are really receiving those benefits that are provided through an energy code update. And so that helps validate whether or not those savings are being realized. And then this specific methodology focuses on individual measures, those measures that have the highest impact on energy use. And so it can certainly help states and jurisdictions, building departments, others, identify kind of where key areas of importance are for developing education and training programs. So, say, primarily homes have high rates of non-compliance with wall insulation, and that non-compliance is mostly the result of poor installation practices. So you can develop a targeted training program around that specific measure and really help the industry and others understand how to improve upon that. And then the last big benefit is utilities are certainly interested in energy code compliance programs and using that to potentially claim savings through an energy code support program. So this can potentially help drive additional investment from utilities in terms of energy code implementation. So a little bit about the methodology. I won't get too in the weeds here, but I referenced the key measures as being a really important aspect of these studies, and that's because those are really the basis for the methodology, the basis for the potential energy savings that are generated. And so there were 8 key measures that were identified in the residential energy code as being the high impact measures, having the biggest impact on energy use in a home. And so the list is here, envelope insulation levels, as well as how well that insulation is installed. So field teams kind of looked at both of those aspects, and then that determined whether or not that specific measure was being complied with or not. Window efficiency, both U factor and solar heat gain coefficients, envelope air tightness, duct tightness, and then high efficacy lighting. And so the methodology requires that 63 sets of each of these measures be collected. So we need, for one complete data set, it is, all 8 of these measures, and we need 63 complete data sets for those, for us to do an analysis at the state level, and for the results from that analysis to be statistically significant and representative of kind of compliance rates across the state. Or if you were to do this analysis at a local level, you could do it at the local level as well, and it would be representative there. And then kind of the last piece is PNNL develops a sampling plan, where it's generated kind of on a semi-random basis. We use single-family permits at the place level as kind of the primary basis for developing that sampling plan. And so jurisdictions that have more construction will also result in more measures being required to be collected there. And then, jurisdictions with less new construction happening, we'll certainly focus on less as the field team and collect, data, less of that data in those locations. Okay, so before I jump into the kind of the new tool that's developed, I wanted to just provide some initial results from that pilot study where that was really just a kind of a proof of concept of this new methodology that DOE and PNNL developed to assess energy code compliance in residential single-family buildings. And so, again, there was the 3-phased approach. Phase 1 was the baseline study. Phase 2 was the education and training program. And then phase 3 was the post-program assessment to determine whether or not we moved the needle or the field teams moved the needle in terms of compliance. And so the difference between phase 1 and phase 3, if it's positive over here in the kind of the 4th column, the annual energy savings column, that means that compliance was improved across all 8 measures, or when you add up all 8 measures, compliance was improved. And so, there was kind of a positive impact in terms of energy savings, emissions reduction, and cost savings. And so this chart is showing cost savings across the various states. And this kind of important to note, this is at the state level. So although Texas, had the most savings, it also has the most construction going on. And so, extrapolated out across the state, it certainly is understandable that they would have the most savings. But if you looked at this on a, per 1,000 homes or something like that, these results and kind of rankings of potential savings change a little bit. And so that kind of helped prove that, this methodology, kind of did what it set out to do. It assessed compliance rates. It was able to turn, those compliance into potential impact. And then it also proved that, energy code training and education can move the needle and have a measurable impact in terms of, energy and emissions and cost savings there. And so now I'm gonna kind of jump into the demonstration of the new tool that we've developed. And so, I kind of went through some of the results of the pilot states. And so now I will go through kind of the results of all of the states where we have data currently for residential single family field studies. And so those states, those 19 states are shown here in the map. And this map is really just a high level roll up of those 8 key measures and just looking at whether or not each observation, was compliant or not. So it's just a yes, no, was the measure compliant or not? And then this is rolled up across all 8 measures for each state. So you can get a sense of, how well compliance is in the state. Although the devil is certainly in the details, and this tool will provide some of those details. And then there's a couple states, Michigan and New Mexico, that are in process of conducting a field study. So we'll certainly have some data to share there as well. And so bear with me while I pull up the tool, go into presenter mode. Okay, so hopefully you can all see this. So this is in Tableau, and it is on Tableau Public. I will share the link at the end of the sets of presentations here, but I'm providing this in the desktop version, so I don't have any issues with the demo going awry. So this first tab is really to that high-level map of compliance. Some description about the field studies and what the key measures and kind of how a little bit of a description of the methodology, a link to our Energy Code field studies page, and so you can click on that and get the reports, and all of the data that's in those reports is also in this dashboard, and this dashboard allows you to compare across states again. So you can filter by all of the 8 measures, and so you can see compliance rates at a high level for those measures for each state. So this is ceiling insulation, duct tightness. So the orange is non-compliant, the green is compliant, envelope tightness, etc. And if you go to all measures, you can kind of get a sense of which measures have the most potential through improved compliance. And so this graph in the lower left-hand corner provides is based on energy cost savings, and it's the potential first-year energy cost savings if all observations, all measures were brought up to full compliance. And so duct tightness has kind of the biggest opportunity for energy and cost savings, followed by wall insulation, followed by ceiling insulation, envelope tightness, etc. And this is representative, again, of all of these states where we've conducted a field study. So this doesn't necessarily mean that your specific state or locality, that this is likely, that this is going to be the ranking of, we'll say impact from improved compliance at the measure level, but it does provide, some sense of understanding in terms of importance and, where other states have struggled with, this type of measure level compliance. And the different colors represent potential savings for each state. And so, Virginia has 1.2 million of potential energy cost savings if if all ducts were brought into full compliance. Similarly, Pennsylvania, right around the same. And so you can see kind of some states had a lot more savings for these measures than others, but you can filter through. It's all interactive, and so you can get a sense that way through this kind of high level tab. But then we can drill down even further. And so this tab is looking at those key measures, those 8 key measures, some description of kind of how to interpret these graphs. Right now, we're looking at envelope tightness, so you can see that. And the dotted vertical line indicates what the prescriptive or mandatory code requirement was in the state at the time. And so for Alabama, the mandatory code requirement was 5 air changes per hour. They had a amended 2015 IECC. This was one of the initial pilot studies, so there's a phase 1 and a phase 3. The green bars indicate that those observations are compliant. Orange indicate non-compliance, so anything to the left of the line here is compliant, anything to the right is non-compliant. And so you can see kind of the breakdown of data for each state, and then for each measure. And then on the right here, you can see the weighted average air changes per hour for each state based on the data that was collected. And so you can see that Alabama made, a slight improvement, at least on the average, from phase 1 to phase 3 in terms of envelope tightness. Maybe a better example might be Maryland. They're on the 2015 IECC, or they were at the time that the data was collected, so that required 3 air changes per hour. So they went from 3.8 average to pretty close to the code requirement on average. So they made a pretty big jump there. And then scrolling down, you can look at potential savings by measure in each state. And so this is, economic savings, so dollar savings at the state level. But we also have this information for electricity savings, gas savings, emissions, and then energy and MMBTUs. So you can filter through those. You can look at it at a per home level. And then you can also compare states. So if you, say, wanted to look at Southwest states, which are also ones that where field studies were recently conducted and finished up, so Arizona, Colorado, Nevada, and Utah, you can just compare those states to see how results compare to. You can look at different measures. So ceiling insulation, for instance, all of the insulation values we provide in U factors. We did collect the R value data, but the reason we provided in U factors is because all of the insulation measures kind of require a combination of R value as well as how well that insulation was installed. And so that's what determines the U factor. We model these U factors and then compare that against the code required U factor. Some states have multiple climate zones, so there's multiple requirements. And so, but the colors still represent whether or not the measure or the observation was compliant or not. And so there's a lot of data on this tab in particular. I think this is, a pretty important tab and kind of the crux of at least the study. It is foundational to it, given that this is a kind of a deep dive into the key measures that generate savings for everything else. Some other tabs, and I think I'm running low on time, so I'll try to breeze through some of these quickly. Average energy use index, through a pretty sophisticated modeling approach, and then the kind of the dark, we'll just look at one state to make it easy. Look at Georgia. So the dark line is the maximum code EUI, or the EUI required if a home was meeting the prescriptive requirements of the energy code. And then the dotted line is the average observed EUI. So out of all the data that was collected, it provides kind of the average across the state. We also looked at installation quality, which I referenced. And so this is a high level of all states. Grade 1 insulation is typically installed per manufacturer's instructions, and it doesn't have as many voids, gaps. Really is going to provide the thermal properties that are intended from that insulation, where grades 2 or 3 have a lot more gaps and certainly degrade the effectiveness of that insulation. So insulation quality was a big area, and really across all states has been a big area for potential improvement. But certainly some states more than others, and then some measures more than others. Ceiling insulation was typically fairly well installed. And then I'll just reference the last 3 tabs here. So we collected measures on HVAC compliance as well as efficiency levels. So there's data there. Lots of other compliance measures. So the field study and measure and analysis is really based on those 8 key measures, but the actual data collection spreadsheet requires that teams collect all sorts of additional compliance measures, and so that's all included in here as well. And then just some general building characteristic information: conditioned floor area, foundation type, number of bedrooms, number of stories. And so I will end things there. We'll provide a link to the online dashboard at the end of the set of presentations, and certainly would encourage you to take a look, and hopefully you can use this as a resource when you're developing training programs and doing other things. And so I'm going to switch gears and introduce our next speaker. So Rob Vieira is the Director of Buildings Research at FSEC. One of the, in addition to, energy code compliance, another kind of key question we get through the Department of Energy is, which compliance method are builders or, designers choosing to comply with the energy code, whether it's prescriptive, or performance, or UA trade-off. And so Rob and his team really set out to understand and answer some of those questions. And they also took it a step further to try to understand whether or not the compliance path you choose impacts overall energy use after the home is built. So, impacts operational energy use. And so I will turn things over to Rob at this point, and then we'll learn about the study that him and his team have conducted. So Rob, if you're out there, if you want to take control, and looking forward to hearing your presentation.
Great. Thank you, Ian. Appreciate it. So as Ian mentioned, we have a project from the Department of Energy. And are you seeing the slide?
Yep, all
Yeah,
good.
We can see it.
I just want to make sure. So we have this project. I want to thank the Department of Energy, Christina Volpe and Jeremy Williams, Chris Perry, and Sue Capita, all in the Building Technologies Office. Ian has been a great help. Anytime we submit anything, he always has great suggestions. I'm very happy to have him sort of overseeing things. We had a number of cooperating utilities on getting the utility data, and the Southwest Energy Efficiency Project, or SWEEP as you probably know them, helped us with some of the key contacts at one of the utilities. So I want to thank those who helped us with this. We're trying to differentiate, what's different between folks doing a prescriptive and performance-based compliance. 2 parts of this work we're doing, we're going to present today. One of those is a survey of building officials. This is one we conducted in early 2020. And then the second part is utility data comparison, where in jurisdictions where prescriptive and performance are done somewhat popular. And so just give a quick overview of some of the interesting code official survey results. We asked, does your jurisdiction enforce a residential energy code? We had 907 people respond to the survey, and 15% of those said no. We didn't ask them any further questions in the survey, the way the survey instrument was. But at any rate, that was the, so only 85% are actually enforcing it, those who responded. 2015 code was at this time, this was in 2020, was the most popular, and 2018 was second most popular. We then asked a little more difficult question, and whereas we had 900 folks answering that first question, only 150 took the time to sort of, or 148 to be exact, to answer this question about sort of telling us how many of each project, how many projects, we sort of broke it up into a couple different dwelling units, and whether they were done prescriptively or performance based. And what we ended up with was these results, which show that about half are doing nothing but prescriptive in their jurisdiction. About 11% on the other end are doing nothing but performance. So, and only about 4% are really doing like 50-50. And we take those results and compare it to the compliance path. You can see then those jurisdictions that are still using the 2006 or 2009 code are largely doing prescriptive. Those that are doing the other codes, a little bit more, fewer just prescriptive type of that. Some of the interesting opinions we got was, why do builders choose the prescriptive path? Got the answer, prescriptive is easier, was sort of a common one. You know, a lot of folks said they don't know, but prescriptive is easier was probably the more common answer. How much time was spent at design, on-site, and follow-up based on methodology? Again, had a large range of answers, stuff, but most popular answers are basically prescriptive, totaled about 2 hours, performance totaled about 3 hours. Which compliance method takes longer to verify? We got mixed results there too, but the most popular answer was that performance takes longer. We also asked in terms of consistency, what are you having? And in this case, we defined what we called good was to meet all required targets. There's fewer errors. Variable, defined as builders are a bit inconsistent. Sometimes important items are missed. Or poor, which is defined as builders' compliance with energy code is often incorrect. And we saw that varied depending you were in a jurisdiction that did mainly performance or prescriptive. And basically what it came up to was not a huge difference here. We had about 8% doing poor, and those who were doing performance, those who were doing prescriptive, 9%, no difference there really. The group in the middle that's mixed, we only had 5 respondents in that group because, as we said, that's a pretty small group. So that gives you sort of an idea, not huge differences along the way, a little bit more time to do the performance according to the building officials than the prescriptive. So we'll jump into the utility bill comparison, which we did in 2 locations. Both are in climate zone 5. That's Fort Collins, Colorado, and Iowa. Because of requirements of the state in Colorado, we had to bin homes into groups of 15 or more. In Iowa, 5 or more. So even when you start with a fairly decent set of data and houses drop out for one reason or another, when you ended up doing binning, they end up, reducing the ability to do statistical significance because you have, instead of having 15 or 5 data points, you have 1. And when you bin into 15 or more, keep in mind, if you've got 25 homes of some certain group, that's basically becomes just 1 bin. So it's even more so than that. In Fort Collins, we had a request to break up the prescriptive into the R value and the res check method. And then we did performance, which was R405 in Fort Collins. And so those were the 3 methodologies we looked at there. We further broke it up depending on whether it was attached or detached. And then we looked at the group of houses that were under 2015 that were built under the 2015 code. We knew the date the permits changed where they started using the 2018 code. And so we portioned those out separately. We had to get, the time we started making the request, we had to, we wanted to get actually 15 months of billing data, which somewhat limited the 2018. We couldn't get very new homes because we wanted to make sure any home we put in this bin wasn't going to drop out, or a few of those dropouts would make our bins disappear altogether. So we had to be a little bit conservative in asking for that data. So the 2018 group isn't as large as the 2015 group in Fort Collins. Well, we ended up with 731 homes in the end that we got data on. And the data we got was in 39 different bins. As you can see, when we ended up getting prescriptive R value, that was the smallest group. We only got one attached bin of 2015 and 3 detached. We didn't get any prescriptive R value for code year 2018. Performance, we got, and prescriptive res check was fairly similar. We got 16 total performance and 19 total res check. Again, with more, the detached code year 2015 was our largest group. Good news is the utilities cooperated very nice with us in Fort Collins for the Fort Collins data. Instead of getting billing data, if any of you have done this, you get billing data and it's grouped together. And so some of the folks may have been billed on, say, March the 3rd for the March billing, somebody else March 30th. Well, the person for March 30th, has March weather. The person March 3rd is largely February weather. One may have 26 days, one may have 30 days in their billing cycle. You don't know the way folks are read. And so if all you do is get billing data and you don't have the billing dates or anything else, as you wouldn't if it was grouped together, then you don't have some of the same weather and other factors. But they formalized by calendar month and the number of days that the billing was. So we got good quality data, we believe, the way they did things as we had asked, which was a great help. And they even provided minimums and maximums for each bin for each month and standard deviation. And then we used, of course, the monthly average usage, is what you'll see in this and the report largely. Home size wise, we're able to, even though, sometimes it's totally different builders doing totally different projects, totally different sizes. That wasn't so much the case. We were fortunately able to, in Fort Collins, to create bins of the houses around the same sizes. So if you look here at the 2015 attached dwellings, what this is showing on the left-hand axis is the living area square footage. And the one bin we had there was about 1,800 square feet. We had two around 1,800 square feet in the res check, and another one at 16, another one a bit larger. And performance, we had a few that sort of came into this about 1,600 square feet here and so on. So we got fairly similar bins often, and the range. Matter of fact, these you don't see there. These bars here represent range. Go up to the top here, you see the largest bins usually have more range. These two bins actually were all one project, same project basically, all 1,800 square feet. It was enough in that project of these townhouses that we got two bins. They didn't look exactly alike when we got the utility data, but they were very similar. And then this is the same information for detached dwellings. You can see again, we got a lot of similar groups, and we had enough houses that we didn't have a large range of square footage within the bins until you get to the largest bins in each group, which are averaging 5,000 square feet or more. This is the same information for 2018, where we had fewer bins, just res check and performance, 2 each for attached, 3 each for res check and performance when we get to the detached houses. So one of the things, because we had bins of similar area, we thought, well, let's look at it just bin by bin. That's one of the ways to look at it, see what we learned. And one of the things we learned was that, okay, we have some that are going to zero gas use. So over here is gas use. And you can see this is heading down to 0, whereas the other one sort of is heading down to about a 10. So we went back and learned that indeed these are houses, this particular bin, houses were all built by a particular builder who uses electric resistance water heating in these attached projects, and then uses that everywhere. He uses electric resistance water heating. Other builders use gas, so we followed and were able to figure out how many electric resistance versus gas water heating was in each bin. The other, sometimes data dropped out for something like gas during the summer, because one of the rules in Colorado is if you're going to provide the data to somebody in these 15 bins, no one house can be more than 15%. And so we're not always sure why things dropped out. We're not told that reason, but chances are during the summer where use is kind of low relative to winter, it'd be easy for one house in the bin, might have some extra gas use. They're grilling out for a party every night with natural gas or something else. And so, you know, one house gets more than 15% of that total energy in that bin for that month, then we don't get any data, which is what I suspect happened in a few cases where we didn't get summer data. Electricity use, you see this follows pretty closely. Again, these houses had electric resistance. The ones on top had electric resistance water heating. And so they're about 150 to 200 kilowatt hours more in that case. And this was done by these were res check homes versus performance, but as I indicate, a little different water heating system. So I want to jump to some of the bins where we didn't have any real water heating difference issues that we are aware of. And this one, the orange, is a res check. The two blues were each different performance groups. These were, you know, approximately 3,500 square feet specifically. This one's 3,484. That one's 1,543, and then the lowest one over here under the gas use was 3,270, and stayed the same in the same shape over here in electricity. So in this particular group, the performance ones used a little less than the res check here in the detached houses of this size. Was it consistent? We go to 4,000. Well, over here on gas, it seems somewhat consistent. We had 3 of the performance groups in this 4,000 square foot size. We had over here on electricity, though, we can see that the res check group actually came down here to be one of the lower groups, equal to, you know, one of the performance groups, so the smaller of the performance groups. If you look at 5,000 square foot houses where we had a bin in R value, res check, and performance, you see they tracked very closely for gas, no real difference there. And when you go look at electricity, you see they're tracking fairly close, although, you know, a little bit more. In this case, the res check was a little bit lower than the performance, which is in blue, or the R value, which is in green. We did so what's it come out, and then that just shows you sort of the bin by bin where we see things very visually. Not so visually is, you know, when you do a linear regression. So when we did this linear regression, where you see green, they're green or red, and these are basically representing the same thing. It means there was some significant difference. Green, you would read this, that the attached 2015 homes using res check and showed a significant statistical benefit. In other words, significantly less gas energy than performance. Got reversed some when you got over here. We say marginally significantly more. The statistic wasn't as strong when we say marginally. So you see some variation in this. In general, when you get to the detached, the performance did a little bit better if there was difference. There's a lot of white boxes. White boxes mean there was no statistical significance. Also point out, in addition to the water heating thing, which we were able to put in a variable for. There was a little bit of unknown of for certain how many homes. Homes were known to have a problem where they added electrical tape to the condensate, I should say condensate line, not condenser, on condensate line that was in the attic. Okay, it was about 5% of the R value cohort and about 65% of the res check cohort. So there's electrical tape on the condensing line because they put the air handlers in the attic, which is not a good place to put air handlers. House size was significant and always showed up statistically significant, isn't surprising there, and went into each of the models. When we look at the mean home size for a group of data where we actually have some significant differences, how much does it really make if we were to use our model? Keep in mind there's a fair amount of error in these models, so this isn't like a perfect thing. You know, we could see that, and this is assuming, because we plug this into the model, that all the house, you know, the house would be 100% gas, have gas heat, gas water heating. We see about a little over 120 therms less for the res check than the performance on the gas side, and about 100 therms more on the detached side, so not consistent. Okay, when we go look at the 2018, we actually had a case here in 2018 where we actually showed a difference. In the gas use, we didn't show any significant difference. Again, you see a lot of cases without significant differences. We do see a case up here. This also had the condensate line tape, and it was much higher res check than performance. Again, performance doing a little bit better every time we see the detached houses, whether it's versus R value or versus res check, if there was a statistically significant difference. So what's the bottom line from Fort Collins? There's unlikely a huge prevalent difference in energy use. If it was huge and it was prevalent, we'd see it more consistently across the board. Okay. However, with the way the bins come out and all, we can't conclude that the methodologies are equal, right? We are seeing a couple of differences. We are seeing some differences some of the time. The utility bill data is a little different. The utility bill data, let me just check something here. Utility bill data in Iowa also is broken into 3 groups: performance and prescriptive, and another group which was HERS plus prescriptive, where each of the homes met the compliance using U-factor alternative or UA trade-off methods, and they included a home energy rating. Okay, the home energy rating didn't have to hit a particular thing, but they included it as part of it. We had pretty detailed data on the HERS plus and the performance group, more than we just get on the prescriptive group in terms of the house characteristics. It was in certain areas that we got data. In this case, we got 130 bins, smaller bins, 750 homes were received. Bins having both gas and electric under the performance, unfortunately, were kind of small, just having 9, but we got bigger groups on the others. We have characteristics. I'm going to sort of just show that the house size on average wasn't too greatly different. HERS plus tended to be more on the large size than the others. Okay. So some of the results we got through looking and trying to get regressions predicting, you know, based on the characteristics we had, it was very poor predicting electric use. We did have a model that was reasonably strong for predicting natural gas use. Trying to combine them just made things worse than just having the gas use. And so we tended to focus on gas use and went to the whole data set. You can see sort of scatters here and stuff. And when we tried to run regression models on it, we did not find that the type of compliance was significant. In other words, how they complied did not show up to be significant. If we broke up the data to look where there are a few more, homes greater than 3,000 and homes under 3,000, and then under 3,000 square foot, we did find things started to show up as significant. We will point out that the performance homes just had a great deal of scatter here. This is a terrible fit if you're going to use a linear regression to represent this data. You can see it's somewhat more all over the board than quasi decent fits that are in the HERS plus and the prescriptive. So what we did find when we looked at that was the HERS plus path used statistically significantly less gas and electricity than the performance cohort, although we'll point out that the performance cohort model is kind of weak. The HERS plus path used marginally, statistically significantly less gas than the prescriptive cohort. And what we mean by that was it wasn't quite as high a coefficient. So in summary, our compliance path in many jurisdictions is dominated by one method, as we saw. In locations where there's multiple types, building jurisdiction personnel on average believe it takes a little more personnel time for performance relative to prescriptive. When we looked at the utility data in climate zone 5 regions, the 2 areas studied, it was not consistently significant. The compliance path was not consistently significant in determining energy use of occupants. In other words, I want to know, which is always better. There isn't going to be an always better out of this. Okay. In some cases, there were significant. So just to review those, in Iowa, we did see that when we parsed it to the under 3,000 square feet, the HERS plus path homes did better than the other 2 groups. In Fort Collins, when we looked at just the detached homes complying by the performance methods, they tended to use both less gas and electricity than the homes complying with res check or the R value method when there was a statistical difference. In some cases, there weren't. But the attached homes did not follow these results. So I'd like to just wrap up what would be other future good studies to do. It's difficult to find situations where both are used in some prevalence, prescriptive and performance. You'd like to find different climate zones where that's happening. You'd like to have very large samples required due to building. If you could get utility cooperation where they sort of did the work in-house and just release the results, that might be a way to avoid binning issues. One of the things that happens is usually a builder is doing all the same compliance method. How do you account for that? Take that out of it. And does exceeding the code matter? I want to tell you there's some reports. So when you get this, there's some reports we have on this. We do not have the report yet on the utility data out. And I want to thank my Philip Ferry, who's principal investigator, Karen Finauti, who has done lion's share of the work you're seeing here today, and my colleague Jeff Sunny on our team, and Jerica Stacy, Dave Walls, and Chris Stenger from our ICC part of the team. Thank you.
Thanks, Rob. That was great. So we have a little bit of time for questions. Let me share my screen again. Okay. All right. So Rob, we'll start with you. So there's a question here. Why do you think there was a variance between performance electric use and gas use? And I think this is for the Fort Collins analysis. Does the electrical use in the performance include plug loads?
The electric use certainly does. It includes everything. So it's a total electric bill. So it includes everything. So there's things that are not covered in code that are in there. Now you can look at, sort of summer and see, okay, well, there's air conditioning. You can try parsing it out. But for the overall analysis, we used the annual electricity. For the gas analysis, we used, although we show graphs there, we're showing year round, we used the winter 6 months for gas use to get rid of some of the differences and things that aren't there. So we use winter 6 months. for gas and all year for electric. Electric will include everything. And we even see a little bump up in December for electric, which might be holiday lighting.
Okay. But in terms of kind of the difference, so I think this one in particular, this may have been one where performance path used less gas and maybe more electricity. And so I think that's kind of, do you have any insight as to why that may be, that you know, performance and performance paths kind of switched in terms of use?
There's a point that, yeah, there were some mixed results in there, particularly
Okay.
in the attached group.
Okay.
Kind of hard to say.
Yep. Okay. So please enter questions if you've got them. There's one here for me. So question about the field studies, particularly for Nevada. So which code was referenced for the Nevada field study? Was it the statewide code or a local code? And so the answer is it was the statewide code. And at the time, it was the 2018 IECC is what we were comparing against for those. Another question about the field studies, why are some of the upper central states kind of not represented here? And just the answer is they just have not conducted a field study using the DOE methodology at this point. So, you know, maybe in the future they will be, and if they do, then we'll include that in the dashboard. But right now they're not. Speaking of which, I will drop the link to the dashboard in the chat. So please feel free to click on that. It's also going to be available on energycodes.gov under the residential energy code field study page. I think we have another question for you, Rob. Did you have the performance calculations for the analysis?
In the case of Iowa, we had the characteristics of the house, and we might have some of the calculated result for Iowa. Yes, not for the others.
Okay.
Not for Collins.
Okay. So we'll go to kind of a wrap-up slide here, but if you do have a question, we might be able to answer one more. But you know, hopefully you enjoyed today's seminar. We hope that you can join us for the next one, which is on October 6th, where we're going to be talking about building to zero energy, zero water, and zero carbon. So we've got a great lineup of speakers ready to talk about that topic. So we hope you'll join us then, and then for the future seminars in the series as well. So if no further questions, I think we'll go ahead and wrap up. Again, encourage you to check out energycodes.gov. Click on the residential field study page. You know, there's the dashboard there. There's also some recent kind of new reports on those pilot studies that I mentioned, comparing all of those states. So I encourage you to check that out as well. But thanks again for joining. If you have questions, you know, please feel free to reach out. You know, we're always looking to help. So we'll end things there. But Rob, thanks again for presenting. It was really, really excellent. Looking forward to seeing the full report. And we'll certainly make sure that folks on this call can get that full report once it's out there as well.
Okay, great. Thanks, everybody.
Okay, thank you.